All right, my darlings, let's go ahead and do a couple of these guys together. So we have a solid frustum, and a frustum is a cone that has been chopped off, which means we're going to need to utilize facts that we know about a cone in order to do this. I'm going to use some actual shapes here. I know many of you saw these shapes when we originally did this, but we'll go ahead and look at them again. So I've got this little guy here, which looks like that, and then here's my green stuff that I kind of added to it. And in this particular case, since it's solid, I'm interested in this clear stuff right here. I also need to know what the base is equal to, and then I also need to know the base that is really kind of, let me see if I can throw one in there, that's kind of hanging out right there at the bottom. So I've got that nice little base that I'm looking at there, and then I also have my nice little base that's on top. So in order to do this, first of all, I need to recognize that the frustum is needing to be parallel to the base, that that's how it was cut. My bottom diameter is 24, which makes that 12. And my top diameter was 8, which makes that 4. And the frustum itself has a height of 6, which puts us right here. Now, I am interested in knowing what the top height of that is, because I'm going to need to take the whole thing and subtract the top part in order to find out this little section right here. So in order to do that, I have x is to, the small is to the whole thing, x plus 6, as the small is to the whole thing. I'm going to just reduce that so I don't have to do as much math. I have 3x is equal to x plus 6, and 2x is equal to 6, so x is equal to 3. So this is equal to 3, and I worked very hard to make a nice pretty little problem for you using your Pythagorean theorem. You've got that that's 5, and then you can use ratios again to figure out what this little value is here. Or what I like to do is just drop in that one right there, which makes this 4 and makes this 8. That's so drawn to scale, right? And this 6, which makes this a nice 10 for our nice little Pythagorean theorem down there. So what I now need to do is find the volume. The volume is the easy one. The volume is you take the entire volume minus the top volume, and you've got your remaining volume. So that's pretty simple. So I'm going to take volume of large minus volume of small. So the volume of the large is 1/3 of the base area times the height, and the volume of the small, is 1/3 of the base area times the height. And I do my little fun of the world here, and I get what? 432 minus 16 is equal to 416 pi. So that's simple. For the total surface area, I need this surface. Well, that's easy to find. That's 16 pi. I need this surface. Well, that's easy to find. That's 144 pi. But then I need this stuff right here. The only way to find that is to find the surface area here, which is just pi r L, minus the green pi r L, and then you're going to be left with all of this stuff here. So pi r L minus pi r L, which is 185 minus 20 pi, which is 160 pi, plus 16 pi plus 144 pi. So again, I have 1 surface, 2 surface, 3 surfaces. I notice did not take total surface area minus total surface area. It just doesn't work that way. You just have different things that some are added, some are subtracted, some aren't even there, some are added in, all sorts of crazy stuff, so you just need to be really careful with that.